Hi again, welcome to another video, and hopefully you might watch the overview of the Pico scope, but in this one you can't use an oscilloscope without looking at scope probes. And believe me, I didn't quite realize how complicated they were until I started doing this video. You'd think after 45 years I'd know a bit more than, but I know a lot more now than I did before, because they're not just a piece of wire that goes from one end of a connector to the other. They're much more complicated than that. Well, what we're going to look at is the TA386 200 megahertz scope probe, but we're going to look at it from a calibration perspective, because all scope probes need to be calibrated, and it's also about calibrating the Pico TA386 2000 itself. So we go through all the different processes that you naturally do when you're starting your day in doing electronics, zeroing the offsets inside your Pico scope, and also then calibrating your scope probe. So these are all really important procedures, especially if you're after accuracy. Okay, so we're going to analyze these probes. We're also going to look at not just the probe, but also you get a little bag of bits like this, and we're going to look at why you get this bag of bits and why these bits are so important. We're going to look at the scope probes from an AC and DC perspective, primarily from a DC first, and we're going to do experiments. So I'm going to go through some basic electronics knowledge. We're going to look at potential divider networks, and also a little bit of AC theory in terms of filters, and also why we have ×1 and ×10 probes, because there's a very particular reason why we actually have them. And also, depending on certain industries you're in, you may actually even have ×100 probes. But hopefully you'll understand through this video why not only we have ×1 and ×10, but in fact why ×100 even exists. Okay, so I hope you enjoy this video, and I hope you learn something from it. Let's see where we start then. So the first thing is that we're going to have an overview of the accessories and the features of the probe. So the BNC connector, BNC stands for Bayonet Niall Conselman, and Niall Conselman were the two people who invented the BNC connector. And this connector is very special. It's actually used in high frequency work, hence the reason it's used on oscilloscope probes, but it's also used on signal generator leads, RF sets and things like that. And it comes in different sizes, but the BNC connector we're looking at is generally spec'd up to about 500 megahertz. So we're going to have a little look at that, and also the what's called the box of the oscilloscope probe and the compensation adjustment. And inside here this is the BNC connector here, and you'll see down the center there's a center conductor, and that center conductor ultimately connects to this point here, but it does go through a lot of circuitry in that process. And this outer ring is actually the shield or the 0 volts, which will connect to your electronics. And so although this is well shielded, what I want to do is show you this. This is a signal generator probe that we're going to be using later on, or signal generator lead. And I just want to show you the importance of connecting this to your oscilloscope. Now, you'll notice that you can turn the outer shell of this connector, and there's a very good reason for that. And also you'll notice it's got a sort of like a slot with a diagonal part and a little pip at the end. And I'm going to show you why this is so important. So here we have our oscilloscope, and what I'm going to do is, you'll see on the oscilloscope, you'll see a little metal stud coming out here, and there's one 180 degrees on the other side. And what you do is you line this up, feed it through, and then when you turn this connector, it draws the whole connector into its mating part, and then it will click into place. This is the box area of the connector here, and here in this probe is our compensation adjustment, which we'll look at in detail shortly. So let's go back to presentation and see what the next bit is. So look at the tip end and the guard ring and the ×1 and ×10 attenuation. So let's go back to our screen, our camera, and here we have the tip end, and it normally comes with this yellow shield already attached. It's there for a reason, because it's there to protect the tip and also to shield the guard ring. And I'm going to talk about that in a minute. So we've got the tip, the guard ring, and in here is a little connector area which you're going to connect your ground leads to, which we'll talk about shortly. And also you've got your switch ×1 in position. You'll see it marked on the actual plastic, so you'll see the ×1 there, and down here it'll be ×10, and so that allows you to attenuate your probe if you need to. Right, okay, here we have the compensation adjustment tool. Let's go back to our camera. So when you get the probe, you'll also get a bag of bits like this, and inside that bag, I'm going to empty this out because we're going to be looking at all the parts in here. So there we go. I'm just going to put that data sheet to one side, and here are all the parts. And this tool here is your compensation adjustment tool, and there are two ends to it. There's the cross point end here, and there's a flat screwdriver end here, and that uses the cross point end, and when you put it inside the chamber you can actually adjust this capacitance, which we're going to look at in detail shortly. So that's the compensation adjustment tool. So let's now go back to our presentation. Marker sleeves. Right, let's go to our marker sleeves. So these are the marker sleeves, and you'll see they're in pairs. So you've got 2 yellows, 2 greens, 2 blues, and 2 reds. And they allow you to color code your probes. So what we do is, I'm going to make this my red probe. So I take one of the red sleeves and I slip it over the end like this, so I can put it as close to the tip end as possible. And similarly, I can take the other red marker sleeve and put it on the other end of the probe like that. And so that now color codes my probe. Now, if I've got all these wires all bunched up and I'm thinking, which one's which, then I can actually just look at the channel, look at the color, and I know this probe is channel A. Now, locating sleeves. So let's discuss those. Now, the locating sleeve, this was the one it came with. So the 2 locating sleeves, you've got the protector size sleeve here, and you got this one here as well. Now, if we just put this one on here, as we push it on, you'll notice it, the tip comes out the top here, which is great. And also it protects this bit, which is the guard ring. Now, why is that important? Well, let's get a board here, which I've got. And this is just a PCB I've got lying around. Now then, one of the problems when you're using an oscilloscope probe is that as you're prodding around and going around your circuit, this guard ring is actually effectively the ground. And so when you've got this connected, this whole scope probe connected to ground, you can accidentally touch this sleeve on your electronics. And this is particularly the case if you've got power transistors or power MOSFETs, where the tabs are actually not necessarily at 0 volt potential, which is generally the case. And so you can end up blowing your circuits because this guard ring has touched some of your electronics. So the best thing to do is make sure you always have your locating sleeve on like this. And this is just one of the 2 variants of the locating sleeve. So this protects the guard ring to make sure it doesn't actually touch any of your other electronics. So we can go around the circuit doing this, but you'll notice that this is fine prodding and probing this circuit, but it's not very stable. So I could slip off and go between 2 pins, and that could cause a problem. So what you can do is the other sleeve, this one here, you'll see has got a funny shape on the end, and that allows it to locate across between pins. So let me just put this one on instead. And so that allows me to actually locate between pins without sliding around. So I'm putting pressure on both up and down on here. And what I can do is move this around, and it won't actually touch other pins. Let's look at the next bit, move back to our presentation, and we've got the hook tip. So let's have a look at the hook tip. So this is the bit you'll probably use more than anything else. So here's the hook tip, and that pushes on over the probe, push it all the way in, and you'll now see there's a little, let me just move this out of the way so you get a bit more of a contrast. You'll see there's a hook on the end, and that allows us to then lock onto circuits or bits of our circuit like this. Now, and also because this shrouds the guard ring, there's no chance of shorting the guard ring out into your electronics. So this works really well. Now, the other thing is that I just want to point out is that this tip here is very, very fragile. And I know how tempting this will be. Here is a piece of board, developed by a breadboard, and it is so tempting to go, oh yes, I'll just stick this into one of these holes and I'll leave it dangling in there. And believe me, you won't have a tip for very long. There's quite a lot of pressure on the cable, on this cable here. And so when you put it into this board, then what's going to happen is you'll end up bending the tip over, and eventually it will snap, because they're not hugely strong, and so it's best to protect this. So I would strongly recommend that you make sure that you've got your hook tip on your probe at all times, really, unless you're probing with one of the locating sleeves instead. Okay. And then finally, let me just go back to our presentation here, and we've got the ground lead. So here we have the ground lead, and that, you'll see a little hooked clip there that slots into the hole and pushes into that chamber, and it locates it. You can then pull it out if you wish, but then pop it back in again. It's great. And this allows us to connect to a ground to our circuit. So this on my board is my local 0 volts, and then I can actually monitor all sorts of points on my circuit, either using the hook tip or putting a locating sleeve on here instead, and then probe around my board. Okay, so that's covered all of the accessories of the scope probe. So let's just go back to the presentation and have a look at what's next.